Okay, in the last video we discussed this number of dimensions or ndim property of any NumPy array, and we also saw an example of defining a three-dimensional array in Jupyter Notebook. Let's discuss another property, which is the shape property. Let's see what this shape actually represents. So let's go to Jupyter Notebook and see what actually this shape represents. For example, you have seen this C as, in the last video, we defined this C as a three-dimensional array that contains two arrays of 2D, and each 2D array contains three 1D arrays, and each 1D array contains three elements. So what do we mean by shape? So if we just say shape, what is that thing? So shape is 2, 3, 3, and let me tell you what that means. The return is tuple, so that's a tuple that is returned, 2, 3, and 3. This 2 means how many two-dimensional arrays are there. Here we have 2. So in each two-dimensional array, how many 1D arrays are there? Well, 3. In each 1D array, how many elements are there? Well, 3. So basically this C.shape 0 tells you the total number of two-dimensional arrays, that is 2. And this shape, for example, 1 tells you in each 2D array how many 1D arrays are there, these many. And this shape, for example, 2 tells you in each 1D array how many elements are there. Well, 3. Great, that's awesome. Yeah. Can I tell you one strange kind of thing? You can define a NumPy array, for example, A as np.array with just one element, let's say 2. That's an array. Great. What's the number of dimensions here? What do you think? What is that? Is that a 1D array? What are the number of dimensions? Strange. It's a 1D array. Yeah, it is. See another thing. For example, B is equal to np.array, and you define it with, let's say, 3. And what are the dimensions of B? It looks like the same. The dimension of B should be 1 as there. The dimension of A is 1. It looks like the dimension of B is also 1. No. It's 0, because that's an array. If you pass it as a list, it's an array of 1D. If you just define just one number that can be defined as an array, NumPy allows you that, but that one number is just a 0D array. Now, if you concatenate a lot of 0Ds, you get 1D. If you concatenate a lot of 1Ds, you get a 2D. If you concatenate a lot of 2Ds, you get a 3D, and so on. Get a look and feel? Yeah. So that's what it is. So yes, in this video I discussed the shape. There are so many properties. Let me discuss some properties. Let's say size. That actually tells the total number of elements, complete total number of elements in the array. So how many elements are there? That is size. There is also, I guess, n bytes property. That tells how many total number of bytes that this structure is taking inside the memory. And there are several other, properties. If you just apply a tab and get certain things, you will see a lot of functions, and you can check a lot of properties. That some of these functions we will explore later on. Sometimes they are called the universal functions. We will see them because they are very, very fast, and these functions, the vectorized implementations of these functions, that is the reason why NumPy is so fast and why it is so popular. Anyways, so in the next video we will go to explore the NumPy a bit more, and we'll show you more fun stuff with NumPy. So hope to see you in the next video. NumPy actually provides a lot of functions to create arrays, special kind of arrays, just for testing, and sometimes just for there are a lot of ways to create arrays from scratch. For example, what if you want to create an array containing all zeros. So there is a function in NumPy, np.zeros, that tells you how to do that. Similarly, if you want to generate a lot of generate an array containing a lot of ones or all ones, there is a function to do that, and stuff like so. There are some functions that are actually used a lot, and I want to discuss those. One function is np.arrange. Actually, this is a single R. This is not a two R's. This is a single R. np.arrange with one R. And np.arrange function, what it does is it creates an array. For example, if you say np.arrange, it creates an array. For example, if you say okay 100, so it creates an array that it creates a 1D array that starts from the values in that array starts from 0, 1, 2, all up to 99. So that's an array. That's a quick way to create an array with all the numbers till 100. Yeah. So let's see a running example of this np arrange method in Jupyter Notebook, just to get a better look and feel of how it works. So let's see. So let's say we have a equals np.arrange and let's say 100. So that's it. If you want to see what is inside a, you can see this is an array with all the values starting from 0 up till 99. Maybe you want to create an array that starts from a particular number, ends at a particular number. Maybe those two numbers are different, and maybe this arrange function actually allows that. And let's say I want to start with 20 and I want to end at 100, and I want to create all the array that does that. So let's say this. So that's okay. Start from 20 and at 100, but the last element, last index is not included. That's possible. Last but not the least, if you want, for example, to start from 20 and at 100, and let's say you want to take a jump of 3, that's possible. Remember, does this resemble with something that you know already? Remember that? Yeah. Let me pause for a minute. Not for a minute, just for some seconds. Let me pause. Do you remember this arrange, np.arrange function? It looks like something like what? Remember that? For I in range, yes, for I in range, for example, start from 20, go to 100, take a jump of 3. Remember that? So it has some resemblance with the range function. Yeah. Although range is an iterator. What's an iterator? Why I'm telling you that? Okay, let me tell you an iterator as well here. Just spend a few seconds on this range function. You might be thinking, when we call this range, let's say starting from let's say range 10, you might be thinking that it returns a list of numbers starting from 0 to 9, but that doesn't happen. It returns nothing. Actually, when you actually call it, it returns just an object. When you call it in a for loop or somewhere, it progressively returns one by one, element one by one. So it returns an element, then it iterates and return another element. Then it never creates a list of elements. It never creates a list for you. That's awesome. Actually, it generates numbers. It generates the next number and the next number as you move on. So it saves a lot of memory. And these kind of objects, they are called iterators that iterate. They never create. But if you want, for example, to get a list, if you really want to get a list, then what you can do is you can call the range, let's say the same way, and you can just write a list. So provide me a list, don't just provide me an iterator, and that will give you a list. How cool is that? Right? Anyways, that was just a side note. It has nothing to do with this arrange function. Anyways, so np.arrange, it actually returns an array. It is not like an iterator. It returns an array, complete array, the way you want. So that's what this arrange is. It has resemblance with this built-in range function that mostly used in for loops. Okay, next let's discuss this np.random permutation. np.random is a package. np is a package. It has a lot of sub packages inside. Random is a package. Random has a lot of modules. One module is permutation. There are a lot of other modules. So let's see this random. Let's see what it does. So for example, let's say A equals np dot random dot permutation, let's say permutation, and what I do is I say okay, np dot arrange, let's say 10. What it does is this np dot arrange will return an array containing all the values 0 to 9. These are 10 values, and then this permutation function that resides in the package np.random, that is in the random package of np, it actually shuffles all the values and rearrange all the values in random fashion, and A will now be an array containing the same elements but in a different order, in a different random order. So let me now print this A. It will be having all the elements from 0 to 9 but in a really shuffled way, and that shuffling is completely random. Yeah, you see that? Sometimes you may call some function, you may want to write some function on arrays, and you may want arrays that do not have a particular ordering, that are just random arrays, just to test your code, just to test how it works on any kind of array. In that case, one way of getting a shuffled kind of array, one quick way is to just use np.random.permutation function. The np.random package does not only have this permutation, there are a lot of other functions. np.random, for example, np.random random.rand int, for example, rand int, that creates a random integer. That's for example, if I let me call this, and we have how can it be used. Okay, we can give a low value from where we start, we can give a high value, and it creates actually random integer starting from low ending at high. So that's how it can be used. For example, let me call it as np.random.randint, create a random number between 20 and 30, create some random integer, and it will return some random integer between 20 and 30. If you call it again, it may return some other it is returning 30 again, 29 again and again. Now it returns 29, 22. Maybe we want to generate random integer between 20 and 30, so it creates a random integer. One thing that you might be noticing, what is the return value? The return value is v, for example. What should be the type of v? What do you think? Is this v is an array? No, it is a number. It's an integer. The type of v should be an integer because it is returning a random integer. It is returning an integer, but it is selecting that integer randomly from 20 to 300. So it should be integer, and it is. Yes. Wow. Yeah. So we will be exploring some more functions in the random package of np, and then we will be moving towards this fascinating function called reshape. So there is more to come for NumPy. So hope to see you in the next video.